Okay, let's talk about limits of rational functions. If there's no danger of getting 0 in the denominator, then literally what you do is you treat the rational function as if it was two polynomial functions. And so here the limit is x going to 2. Well, there's no danger of getting 0 in the denominator. So therefore I literally plug 2 into the polynomial. 2 to the third is 8, times 5 is 40, plus 4 is 44, 2 minus 3 is negative 1, and so the limit as it evaluates should become negative 44. And so that's what you do when there's no danger of getting 0 in the denominator. Okay, what if there is a danger of getting 0 in the denominator, like here? Well, factoring is going to come and save the day. So in other words, I factor the x squared minus 4. That gives me x minus 2 times x plus 2, and I can eliminate the common factor. And now I have x plus 2. Now remember, this is the limit as x goes to 2. And so while 2 is a whole, I'm just approaching 2. And so the limit here is going to be 4. And so here, factoring saves the day. Example 5. How do we treat a problem like this? Well, notice 3 is a problem, because that would give me 0 in the denominator. And so what I'm going to do is I'm going to factor again. And so I factor x squared minus 6x plus 9. That gives me 2 factors of this. I eliminate one of them. And so the limit is 0. Part B. What is the limit as x goes to negative 4 of 2x plus 8 over x squared plus x minus 12? Okay, so what do we do there? Take the polynomials in the numerator and denominator, factor them so you can eliminate the common factor of x plus 4. And that leaves me with 2 over x minus 3. Put negative 4 into the expression, and so the limit is negative 2/7. If the limit of the denominator is 0, but the limit of the numerator is not, then there are 3 possibilities. Possibility 1, the limit may be positive infinity. Possibility 2, it may be negative infinity. And possibility 3, it may be positive infinity from one side and negative infinity from another side. And so these 3 graphs reinforce that concept. All right, let's go ahead and find the following limits. The limit as x goes to 4 from the right of 2 minus x over x minus 4 times x plus 2. The limit as x goes to 4 from the left, 4 from the right, 4 from the left, of 2 minus x over x minus 4, x plus 2. And the limit as x goes to 4 of 2 minus x over x minus 4, x plus 2. Let's see how they handle this situation. So, in all 3 parts, the limit of the numerator is negative 2, and the limit of the denominator is 0. So what they do is they draw a number line, like we did in pre-calculus, and they test the number line for the sign value, whether it's positive or negative. And so from this, we can see that if we approach 4 from the right, we're going to get negative infinity right here on this number line, negative infinity. And if we approach 4 from the left, we can see we're going to get positive infinity. So that means that the right-handed limit is negative infinity. The left-handed limit's positive infinity, but since the two disagree, the limit itself doesn't exist.